is a quiz on right triangles. All right, so now let's go to law of sines. So the world is filled with lots of triangles that happen to not have a right angle in them. And so we're going to learn the formulas for the law of sines. And then we're going to learn when do I use them, and then we're going to use them to actually solve either a missing side or a missing angle in a triangle that is not a right triangle. So this is, well, I'll zoom in on this part here. This is the law of sines. And the way they name the triangle is that the angles, all three angles, are notated by capital letters. The sides are notated by lowercase letters. And the side lowercase c is always opposite the angle capital C. And the same is true for B and for A. So when we go to solve, based on the information given, we're going to pick two of these fractions to equate to each other. So we're not going to use all three of them. We're just going to choose two of them. And it's going to be based upon the information you were given. So we're going to say the angle sine of A divided by the length of its opposite side. Let's say we worked on just the first two. The sine of angle B divided by its opposite side. So we're going to just be working, let's say, with these first two for the problem we have. Then I need to know three of the four missed parts. So when I say an angle in its side, an angle in its opposite side, to solve it, I need to know three of the four. So maybe I'm trying to find side A, and I need to know the angle opposite it. And then I need to compare it to, equate it to an angle that I know and the length of the opposite side we know. So for example, maybe to solve a problem, you're trying to find the length of angle of the length of the side A, lowercase a. I know the length, I know the measure of its opposite angle, which is capital A. And then over here, I know an angle and the length of its opposite side. So this is how we would set up the formula. And then we would go about trying to solve for A. And the way that we're going to go about solving is this is a proportion. And in a proportion, you solve it by multiplying the cross products. So I would say A times the sine of 112 is equal to 8 times the sine of 14. And then I would isolate my A. And these are not standard angles, so I'll be putting them in my calculator. And I make sure my calculator is in degree mode. Now, in another triangle, maybe it's side angle. This time, instead of the side, I'm trying to find the angle. So I'm trying to find angle C, and I know the length of its opposite side. And then over here, I happen to know this angle and the length of its opposite side. So again, I'll do the cross products, and then I isolate the sine of C, and then to calculate C, I'll actually do the inverse sine so that I can figure out the value of C. So that's the general process of how we go about using the law of sines. So I won't ever be doing three things equal to each other. That's just a way they show the relationship. Now, how we've talked about before with the, like I just said, the capital A, the B, and the C represent angles, and the lowercase a, B, and C represent opposite sides. But we're also going to get into how do I, based on the information I've been given, because again, we have 3 sides and 3 angles. Usually they're going to give you 3 pieces of information. So, and based upon the type of information and positionally how it is located within the triangle, then we give it these names, these possible names, where S represents a side and A represents an angle. And again, we're talking about the 3 parts that we were given. So let's go over each one, and the order, the sequence of how it's listed is important because like here, this has 2 angles and a side, and this has 2 angles and a side, but they're not the same because of the position of the angles to the side is not the same in this triangle as it is in that triangle. So having said that, let's look at each example. We're to start with this one, straightforward. If you're given the length of all 3 sides, but not a single interior angle, then this is called a side-side-side, or SSS triangle. All right, now the opposite of, now let's go to given 2 sides and an angle, but what the angle given where it is different than if it's SAS. Okay, so side angle. As I go around the triangle, I'm going to go around clockwise. Notice I see side, and then the angle. So this is side angle, SSA. Now the next one has 2 sides and an angle, but notice the A is in between the 2 sides, indicating that the angle is in between the 2 sides given, not to the side of it, not to the, at the end of it. So side angle means I'm not given the angle in between them, but side angle side means I'm giving the angle that's in between the 2 sides that I was given. In other words, the 2 sides I was given form the legs of the angle. Okay, so any question in between these two, hugely important because it does make a difference of whether you're going to use the law of sines or the law of cosines. Any questions on that difference? Okay, so let's go over now to some other ones. Now, we could also be given 2 angles and a side, but based upon where the side itself, is it in between the 2 angles or not, then it's named differently. So these both have 1 side and 2 angles, but the placement is different. So again, this would be your given information. You've got a side, and then as you go around, you know the angle, but I don't know the side that's between the angles, and then another angle. So I would read this as side, angle, angle as I proceed around the triangle. Now, angle side angle's different because as I read it, it goes angle, and then the side, and then the angle. So the side that you're given the length of is in between the 2 angles that you are given. So this would be angle side angle. Now, lastly, in the 3 informations you're given is all 3 angles. Now, the problem with being given all 3 angles, but no side, is that we cannot solve it because there are an infinite number of triangles that have the same 3 angles. But all of those angles are what are called similar angles. They're similar because the length of their sides are proportional. But without knowing one side, I can't fix the length. I can't fix the length of the other sides. So if I don't know any sides and I just know the angles, there's a whole infinite set of triangles that look like that, but I can scale them larger or smaller, but I can't find the length of the side without knowing one of them. Okay, so AAA we will not be working with, but we will be working with these other 5. So knowing when do I use the law of sines versus the law of cosines, I'm going to use the law of sines for these 3 types of triangles. So and really another quick way to say it is, if I know 2 angles and a side in any order, 2 angles, that's going to be law of sines. If I know 2 angles, if I was given 2 interior angles and 1 side, that's going to be law of sines. So I know an angle, side angle, and a side angle, angle. I can do law of sines. However, this is the only one where I'm given 1 angle and 2 sides that I can use law of sines. So this side angle is, I can also use law of sines for that. Okay, so now going to law of cosines. When do I use it? We use law of cosines for these 2 types. So side to side, where you're not given any angles, just the sides, automatically, you know that's law of cosines. And then lastly, where I have 2 sides in the angle, but the angle is in between the 2 sides, so it's side, angle, side, automatically, you know that's law of cosines. Okay, so you may want to have that written down or print off this page or whatever. When we start mixing it all up, it's important to know, based on the 3 pieces of information that you were given, which method I'm going to use, law of sines or cosine. I mean, at some point when you're trying to do it, you realize it's not working out. If you just said, well, I'm just going to use law of sines, and then you find it's not working out and you get frustrated, better to know right from the start, oh, I'm supposed to use law of cosines for that because it is a side angle side. Easier just to go right to the method you want to use. All right, so now let's talk about just name. So because the type it is so important to know in which method to use, let's first name the information that you were given. And it's not the information they're trying to find, it's the information that you're given. And so based on what we were just saying, what's the name of this type, and do I use law of sines or cosines? So looking at problem number 1, ignoring the X and looking at the information you're given, what would I call this triangle? Anybody want to step out and say? Anybody want to give some letters to it? I'm talking about A's and S's. What is this? Y'all are not saying anything. Okay. Well, let me say it then. This is, we've got an angle and we've got an angle and we've got a side, but the order we listed is important. So we're going to read it. we've got what? Angle, side, angle. So if we have angle, side, angle, we use the law of sines. Now let's go to this one. Based only on the information given, not on the information you're trying to find. Okay, so Brandon is typing. Were you typing by mistake or typing on purpose, Brandon? Mistake, okay. Now again, I want to look at the information. I notice that I have two sides that I have been given, and notice I'm given an angle. So I'm given an angle and a side. So now I need to figure out the order. So I'm just going to go around the triangle and read it. And notice that the angle is in between the two sides. The two sides form, the length of the two sides given, form the angle that I'm given. So this is side, angle, side. Side, angle, side is law of cosines. And now let's look at number 3. Okay, I'm given a side and I'm given two angles. What's the order? Well, this would be side, angle, angle. And side, angle, angle is law of cosine, law of sines. Okay, so on the next page, it's all said. So we had angle, side, angle, law of sines. Angle, no, side, angle, side, law of cosines. And side, angle, angle, which is law of sines. Okay, so now we're going to use law of sines to find the missing part. So we're going to use those two, we're going to pick. You can go ahead and give them names if you want. You could call the angles, you could call this A and B and C, or you could give them names. And then the opposite sides, you would name them. And notice this is actually going to be a two-step process. And I'll give you a little hint about law of sines. Since with law of sines, for most of the time, you're going to be given two of the interior angles. Occasionally, you're not going to need to know the other interior angle, but most of the time, you're going to need to find the other interior angle. Now, how do we do that? Well, we know that the sum of the three interior angles in any triangle always adds up to a certain number. So what are those three angles always add up to be? The sum of the three interior angles is always equal to what? 180. Brandon said that, and he is correct. Okay, so I could say 180, subtract 40, subtract 31, and that would give me this interior angle. Now, how do I know when I'm going to need to do that with law of sines and when I don't? Well, I'll tell you right now, we're always comparing side to opposite angle. So because I was given the length of this side on the bottom, a length of 7, I will need to know its opposite angle to do law of sines, because we're always comparing the side to its opposite angle. And then I'm comparing this side that I'm trying to find to its opposite angle. So let's look at how we set that up. All right, so we're always doing that comparison. I know this side, I need to know its opposite angle. I'm trying to find this side so I compare it to its opposite angle. So, but I don't know the measure of angle A, but I know the two angles, so I can calculate it by saying 180, subtract 40, subtract 31, and now we see that angle A is 109. So I've calculated that angle A is 109, and because that is the length, the angle opposite the only side I'm given, I'm going to have to use that relationship, that the sine of 109 divided by 7. Now the other relationship I equal it to is the side I'm trying to find and its opposite angle. So I'm going to use the sine of 40 divided by x, which I also called c. Arbitrarily, I called these two c. Now I'm going to try to solve. So now notice I took these three parts that are known, and I'm going to use it to find the one part I don't know. So the first thing you do is you cross multiply. So c times the sine of 108 is equal to 7 times the sine of 40. Now this is multiplication, so now I divide both sides by the sine of 108 to isolate my c. So this is the exact answer. Now I put my calculator in degree mode, and I can do this in one step. I can say 7 times the sine of 40, make sure you close the parentheses, divided by the sine of 109, and I hit enter, and I'm going to get this irrational number, and then I'll round it to however many decimal places they want. Okay, anybody have a question of how to solve this problem? The law of sines is not hard to use. I did want to tell you just a quick story. I've mentioned it before, and actually I had the student whose father was actually he was on the staff here, but his parents had been born in Africa. And then when he reached the age where he was taller than his mother, he got sassy with her. And so then the father said, and the mother said, okay, we're sending you to go to school with your grandparents in Africa, and so that you can learn to be respectful of your parents. So he did, and then he came back here and went to school here at Coastal. But what was interesting is what in that country, when they do not teach what we teach with SOHCAHTOA, or please excuse my dear Aunt Sally. So when they have a right triangle, they solve it using the law of sines. And I didn't know that, and I couldn't understand. I thought he was just not understanding that you don't use law of sines when you've got a right triangle, you use, SOHCAHTOA. And so I talked to him. He said, no, this is how we're taught. So what they do is one of their angles would be the 90-degree angle. So like if you know the hypotenuse and you know this angle opposite is 90 degrees, you can still use law of sines doing it that way. And it, because I saw that he was getting the right answer, but I couldn't understand why he was doing it that way. So just to kind of tell you, in some countries, in some places, they do teach it a little differently, and they all use law of sines to solve right triangles, and it works. So just keeping that in mind. But anyway, so that was an interesting thing that different countries do things a little differently in their mathematics. But they're all doing things legally, so they're still coming up with the right answer. All right, so now I will tell you that law of sines is often used you know, I could go into even military battles or defending forts. It's and we'll go into this some, but this triangulation, which was done for people who become surveyors before they had all the fancy equipment that uses the ultra red wet, you know, spots, the laser spots on stuff that can do it for you. They always use law of sines, because what they would do is they would have 2 points a fixed distance apart, and then they would calculate the angle between them. So the angle to this point and the angle to this point, and two things are a fixed difference apart. That triangulation is based on law of sines, and that is how they could determine how far away this object is. So tracking this satellite, an example of that triangulation is this. A satellite orbiting the Earth passes directly overhead of one of the observation stations in Phoenix and in Los Angeles. Now, they are 340 miles apart. At the instance when the satellite is between the two stations, its angle of elevation. Now, angle of elevation means to come up from the horizontal. So this is an angle of elevation. This is an angle of elevation. Is observed simultaneously, so at the same time. It's 60 degrees from the horizontal in Phoenix, but 75 degrees in Los Angeles. From that information, they can figure out the length, the distance the satellite is from Los Angeles, and the distance the satellite it is from Phoenix, using the law of sines. So now this is their fixed distance, 340 miles apart. We've got our angles. So this is angle, side, angle. So that's law of sines. Now, we know this side. So like I said, when I'm working these law of sine problems, where I'm given two interior angles, 90% of the time, if not more, I'm going to need to find the other interior angle, because it's going to be opposite the side I'm given. So the first thing we're going to need to do is figure out the third interior angle by saying 180, subtract 75, subtract 60. Then once I find this one, I'm going to say the sine of this angle C divided by 340 is equal to, now, which pair of information? It depends upon which side am I trying to find. So you really have to be careful. They want to know how far it is from Los Angeles, so we're trying to find side B. So we're going to compare it to angle 60. Okay, so let's set this up and solve. So we know that we have to find the measure of angle C, because it's opposite the only side we know. So it is 45 degrees. So we're going to say, and I called this C, it's already labeled A, C, and B. So this is B, and this is A, and this is C. So we're going to use this pair of opposites, angle 45 and 340. Now we're going to use the pair of the side they want me to find. So that would be 60 to B. So I do my cross products, and then I divide by sine of 45, and this is what B is equal to. Then if I put this in my calculator, we find that the satellite is about 416 miles away from Los Angeles. Okay, anybody have a question on that one? Now, a lot of you have told me you had all of this in high school. Did you have law of sines in high school? Did y'all have that before in high school? Anybody? Anybody have this before in high school? Okay, so Landon said he had this in high school. And Brax, I think so, but I was 15, so I don't really remember it. Yes, I understand. Okay, so it's helpful to go over it again. This is really important, this triangulation, because this is the basis of, you know, in some of those movies where they have, they're trying to catch, like, what's those, the Bourne Identity, like they were trying to, you know, catch this guy, and he knew that he could only have a certain amount of time on the phone, and then he'd have to disconnect it, otherwise they could pinpoint his location. And that's because if you have certain, again, you're trying to pinpoint something by comparing it to this point over here and this point. So it's still that same kind of concept where they're trying to pinpoint the distance from various locations to pinpoint the distance. Now, another point of this, though, is a lot of times we don't want to know how far is it from Los Angeles or from Phoenix. We want to know how far is it from Earth. And so you're saying, well, I thought you answered that when you said it was 416 miles from Los Angeles. But the point of the matter is distance is always shortest distance. So the shortest distance from the satellite to Earth will be where it drops an altitude down such that it meets the Earth at a right angle. So distance is always shortest distance. Shortest distance always meets this where you're going at a right angle. That will ensure the shortest distance. So we're going to drop a straight line down to this Earth where it meets the Earth at a right angle. And that's the distance we want to find. So what we're going to do is we're going to subdivide this big triangle into two triangles such that they're both right triangles. And then we're going to then find that side. So distance from the Earth is always going to be the shortest distance, which meets the side at a right angle. Now notice this right side is a right triangle and the left side is a right triangle. But because I already know the length of side B now, I want to use the left triangle. Now, this is what I was saying, how that student learned that he could do law of sines. I'm not going to do it here, but what they would do is he would say the sine of 90 degrees over 116 is equal to the sine of 45 over D. And then the sine of 90 degrees was 1, right? Isn't it 1? The sine of 90 degrees, that's pi over 2. So that would be 1. The sine of 90 degrees is 1. And so that's why we don't do it that way. Could do it that way, but we don't. But this is why it works, because if you put this, the sine, because we would, we're saying 75 over D is equal to the sine of 90, which is 1 over this. When you do the cross products, you get this. All right, so but we just set this up using opposite over hypotenuse. Now, why do we use opposite and hypotenuse? Well, I've got this angle I know, which is 75, and I come in this leg over here is D, it's opposite. B is the hypotenuse. So we're going to say opposite over hypotenuse. Here we have our right triangle ratio. And now we solve for D. So we're going to multiply the 416 over to this side. And D is equal to 416.41 times the sine of 75 degrees, which is approximately equal to this. And as you can see, it is a shorter distance than this kind of diagonal distance. Okay, what questions do you have about this? Anybody have a question about this one? All right, so let's go to another one. Now this is one kind of like in the homework. It's similar, but a little different from what we just did. It's still a angle side angle, except for the fact of the angles that they gave. The information given is one angle on the inside, but the other angle is on the exterior of the triangle. So what I'm going to need to do is figure out what would be the angle on the other side of this line that's within the triangle. And we have to use the fact that these two angles form supplementary angles. That is, the two angles, the one on this side and the one on this side, where the bottom is a straight line angle is 180. So I'm going to need to say 180 subtract 87 to get the angle that's on the inside of the triangle. But this is a very, very common thing that they would do in surveying, where the two angles would actually be both on the left side. Okay, so again, once I do that, I'll know this interior angle, I'll know this interior angle, and then I still will have to come up here and find the third interior angle. Once I do that, then I do my law of sines. Now, what is it they want us to find? Which side? How far is station A from the satellite? So they want us to find this side over here. But you do have some homeworks that look just like this. So that's how you would do that. So let's do it. All right, so we know the first thing I would do is find all my angles. So I know this angle that was given, and this angle was given, but these two form supplementary angles that are 180. So I'm going to say 180 minus 87. Now that's going to give me the angle on the inside. Now I know the two interior angles, so I'm going to have to find my third. So I'm going to say 180 minus 93 minus 84.2. And this angle up here is very small. It's very tight little angle. It's 2.8 degrees. So it's a real small, tiny angle. So this thing is not drawn to scale. So now I need to find the length of side B. So I want to use the relationship of this angle B to its opposite side, and then this angle C up here to its opposite side that was given. So those are the two fractions I'm going to set up. And so this doesn't look right. Let me see what's wrong. What's going on here? Why is it 340? Something's not right here. That's not right. Okay, so we've got 84.2 over B is equal to the 2.8 over 340. That's not right. It's supposed to be 50. Huh. Let's get that fixed. They're 50 miles apart. Okay, so we're going to take this and fix this. So let's go grab this and fix it. Okay, so coming down. It was just left over from the previous problem when I did it. It just didn't get changed. The answer, the number may be right, but the answer's not, but it's not set up right. So let's go ahead and fix that. All right, so, okay, so we said that the distance down there was 50, not 340. So let's go ahead and change that to 50. And then let's make sure the calculation is right. That looks too big. Let's make that smaller. That looks maybe a little too big still. Maybe that's right. Okay, so now we're going to do 50. All right, so now this is right. So the angle 2.8 compared to its opposite side 50, the angle 84.2 compared to its opposite side B that we're trying to find. So now we're going to do our cross products. I think this was the right angle side there. So we're going to replace that with 50. And then we'll multiply and we'll get our answer. Okay, so let's put it here. And then we're going to put it there. Okay, so using our calculator, let's see if we're getting the right answer or not. Okay, so you want to make sure you're in degree mode. So I'm in degree mode. And so now I'm going to say 50 times the sine of 84.2. Close my parentheses. And then we're going to say divided by the sine of 2.8. And we get, and the answer's correct. I just didn't have so the answer is correct, but the part inside the middle there was not. So let's replace this and then we'll keep going. All right, so. Okay, so I'll update what's on the web after class. Okay, so now let's go to any problems on, well, that's the end of it. So that's the end of the lecture there. Anybody have any questions about that? Well, I want to go back to this problem here. Well, I'm trying not to confuse you, but I wanted to show you how they did this person, the student, had learned to solve a right triangle using law of sines. And I don't want to try to confuse you here, but let's show that you could have used law of sines with that. So I want to go up to the top. I got too far. Well, let's take that and let's show how we still do get the right answer. All right, so what he said that they would do is they would use the right angle as part of the law of sines. So he would say that they would say, we're going to say the sine of, so they would say we're going to use the sine of the 90 degrees. Oh, I'm sorry, I'm having to do this with the keyboard. It's like doing Etch-a-Sketch. It doesn't work as well. And we compare it to the opposite side of 90, which is the 41. And then it's the 41. I know this probably looks awfully, that's one, that doesn't look like a 6, but it's supposed to be a 6. But it's not looking like a 6. But anyway, there you go. It's worse, but maybe better. I don't know. All right, so now we come over here. Now we're going to say the sine of, now we're going to do this angle 75. Let's show that it does work. So this would be 75 over its side that we're trying to find, which is D. Okay, so if we do the cross products, we get D times the sine of 90. So we get D times the sine of 90. But the sine of 90, I'm going to go ahead and clean up what that is. Let's see. If we were to redraw, do this whole thing, my stylus is broken. This is the problem that I'm having. The sine of 90 is 1. The sine of 90 is equal to 1. So what happens is what you're doing when they would do this, and I'm not saying to learn to do this, but I'm just kind of showing you so you would be aware, particularly if I've got any teachers in here, because you do get international students. But the sine of 90 degrees is 1. So now if I replace that with a 1, notice that when I do the cross products, what do I get? I get D is equal to 416.41 times the sine of 75. And so what I was saying is he was working those in this way. And because the right angle in a right triangle is a known angle. So just saying. Anybody have any questions on this lesson? Anybody have any questions on this lesson? Okay, anybody else? Well, this is law of sines. So next, when we come back next week, we're going to do law of cosines, which is usually going to be when you have a side angle side, where you only know one interior angle. So there's not a way, so we're not going to be able to find the other angles, so we have to use a different method. Anyway, thank you for coming. Appreciate your being here, and I'll see you next week. Have a good weekend.